Welcome to this class on Poisson distribution. Poisson distribution models the probability of a given number of events occurring in fixed interval, whether it's time or space. It occurs with a known average rate represented by lambda, assuming events are independent and occur at a constant rate. So let's take a quick look at the formula. The E here is the Euler's constant, okay? Then we have minus lambda. Lambda is the average rate of occurrence, while X is the number of occurrences. And when we look at scenarios and questions, we will understand how this works. We are dividing that by X factorial. But when we come to look at the syntax in Microsoft Excel, since we are using Microsoft Excel here, you see that we use the function Poisson or Poisson.DIST, which means distribution, okay, to calculate Poisson distribution. And the syntax is equals Poisson distribution, then we have X, then lambda, and the cumulative. So we are going to see how this works. For instance, let me come to the side here and say equals to have Poisson. So you see that the Poisson dot distribution returns the Poisson distribution, right? So we have the X. The X now is the number of events that we have to calculate. Then the lambda is the same as the mean, right? So if we enter the X and we say comma, the next will be to enter the mean, which will be the lambda, right? And the next will be to enter the cumulative, which is either true or false. We enter true if we want a cumulative distribution function, or we enter false if we want a probability mass function. So this is what we have put down here. X is the number of events to calculate, while lambda is the average rate or the mean, okay? By the time we apply this, when we apply this to Microsoft Excel, it makes things a little easier for us to understand. Let's look at the first scenario that we have, calculating exact probability, okay? And we have a scenario here. Say a call center averages 10 calls per hour. What is the probability of exactly 12 calls in an hour? So we can use Poisson distribution. This question is a classical Poisson distribution question because it satisfies the definition of what Poisson distribution is all about. So if we look at this scenario or this example here and go back to our syntax, you could basically determine what X is, what lambda is in that scenario. We said a call center averages 10 calls, right? So the average here will be the lambda, right? And then the question, what's the probability of exactly 12 calls in an hour? So we have X being what? The number of events to calculate. All right, so it's going to be easy for us to go ahead and calculate that. Remember again, our syntax, right? As easy as just entering equals Poisson.distribution. Then we know our X, we know our lambda, then we know what cumulative we have to select. Let's go ahead and calculate for this. So we'll say equals Poisson distribution. So you can just double click on it to pick that. So our X here is 12, right? Comma, our X is 12, right? Our mean is what? 10, right? So we'll say comma. Then we want what? We want to return a probability mass function instead of a cumulative distribution function. So we are going to be picking false. We close our parentheses and hit enter. We have this as the probability now. So I just want to represent this. I'll say equals. I'll just pick this now, it and have it here. So let me represent this in percentage, okay? So basically, a call center averages 10 calls per hour. What is the probability of exactly 12 calls in an hour? So the probability of exactly 12 calls in an hour will be 9%, okay? So if you want to enter more decimals, you can have 9.48% or 9.5%. You could also calculate this example manually, okay? We will say equals, we open parentheses, and we want to use the function exp that returns e raised to the power of a given number. We open another parenthesis, all we need to do is to enter the value for lambda, which lambda represents our average. It will be minus 10 instead of minus lambda now. So we'll close this and we'll say multiply. So shift 8 will give you multiply. So lambda, remember now again, is what? 10, because that is our average call per hour. So we have 10. Then remember that in our example, we have lambda to the power of x, isn't it? X in this case now is 12. We have x as 12. So let's insert that to the power symbol. Okay, this is it. So the power of 12. Then we want to close this parenthesis now. When we close the parenthesis, what we want to do is to divide by the factorial of x. Remember, that is what our formula states. So we'll say fact. Fact returns the factorial of a number. Open parentheses. Our x is what? Remember, it's factorial of x. So our x is what? Our x is 12. So we now close our parentheses. We can just look at this formula again. This is us calculating our Poisson distribution manually. We have equals. We open parentheses and we use the exp function in Excel that will say returns e to the power of a given number. And in our formula, we have e to the power of minus lambda. And lambda is our mean, isn't it? Then we close the parentheses and we'll say multiply by now lambda to the power of x, right? And lambda is 10, x is 12, right? So we divide all of these by 12 or x factorial. How we write x factorial here in Excel is we write fact. Here is a factorial, then the bracket. Okay, so we are done with the first scenario, which is exact probability. Let's look at a cumulative probability now. Now, we said here, what is the probability of receiving up to 5 calls? Now, you see that this is still a drawing from our first scenario here, because we need to use the average of 10 calls from here. So what's the probability of receiving up to 5 calls? Our x here is 5. So we are still going to be using lambda, which is our mean or average rate from the first scenario. So let's do this. And we'll say here, we'll say equals Poisson distribution. Our x is 5. Our mean is 10. That is the lambda. We are going to pick true. So say true. Close your parentheses, hit enter, and we have a cumulative probability. All right, so let's go to the third, which is visualizing the distribution. We want to create a probability table, right? Where we have the column X and the probability column. So what we need to do now is to create Poisson distribution for each of these rows. We are going to say equals Poisson distribution, our X 0. So the next is our mean, and our mean is in A24. But again, we have to ensure that we hold this A24 a constant. So we are going to make it an absolute cell by using F4, right? Comma. Now we want a probability mass function, so we'll use false. So close the parentheses and hit enter. The reason why we had that way is because of the way the values were. So that is why I put it on numbers and then increased decimal so that we have the actual numbers, so that we can see the actual numbers. Okay. So now, if we autofill this, we can just come here, double click. So we have a Poisson distribution for all of these values. Okay. So this is what we have. All right. So if we say, let's call this column manual for X, and we say manual is calculated by, we'll say equals, we open our parentheses, and let's use the function exp that returns e raised to the power of a given number, which we want to know in our formula, we have e to the power of minus lambda. So we open another parenthesis, and we'll say minus lambda, in this our case now is 10, which we calculated the average of these numbers 0 to 20. All right. So we close our parentheses. As we close our parentheses, we say multiplied by lambda to the power of x. That is what we have in our formula. So here lambda is 10 and x right now is 0, right? We'll say to the power of 0. Let's pick that in insert and then go to symbol and take that, yes, this, close. So the power of 0, right? 0, that is x, right? So let's close this parentheses, then divide this by factorial of x, in which our x is 0 here. So factorial of 0, close our parentheses and hit enter. So you are going to see that we have exactly the same number as the same result as we had earlier. Okay, it's exactly the same result as we had earlier. Our average is static, so we can use minus 10, right? We can still have it as minus 10. Then we want to multiply a lambda, which is our average, is still static. So we can change this 0 to this range, A2, right? And factorial of 0 to, so what is only changing is our x, right? So factorial x. So if we have this, our lambda, like I said, remains the same. It remains minus 10 here in this expression. Then it remains multiplied by 10 here to the power of what? Our x. So only our x needs to be dynamic, right? We hit enter. So if we kind of autofill this, okay? If we autofill this, you are going to see that we have exactly the same results, right? This is us calculating manually, and here we calculate using the Poisson distribution function here in Excel, but here we just basically calculated it manually. So you see that we have exactly the same answer for both. Our goal here was to visualize this distribution, right? So what we need to do to visualize this distribution, we are going to be entering a line chart. So let's highlight our first x and our probability or Poisson probability for x. And then we go to insert and let's go to all charts. Okay. Let's pick a line chart this way, and we can see our probability. Okay, so this is what our probability was from 0 up until 20. Okay,